Hello, this video is for your assignment on Tuesday, December 10th for Integrated Science 10. So first of all, you guys are going to open these two documents from Google Classroom. This document that I have says Periodic Trends Graphing. This is a Google Sheets and it contains data of the first 36 elements on the periodic table. The data includes their ionization energy, atomic radius, and electronegativity. And when I return on Wednesday, we'll talk about those three vocab words and what those mean. The second document that you guys are going to need to have open is this Drawing the Trends document. And you'll use this second after you have created your graphs. So we'll come back to this here in just a little bit. So on this sheet, what you guys are going to do is we are going to graph. We are trying to see how do each of these properties change as we go down the periodic table. So let me pull up P-table really fast and show you that what I've done is I've copied these in order of the periodic table. So starting with the first atom, hydrogen, its ionization energy, its radius, its electronegativity, then helium, lithium, beryllium, moving all the way down to krypton. So I'll just show you that again. So starting here at hydrogen to helium, and then going all the way through the second period, the third period, and the fourth period up to the 36th atom, which is krypton. So what we're going to do is we're trying to answer this question, like what kind of trend exists for ionization energy, atomic radius, and electronegativity on the periodic table. Because if you go to periodic table under properties, you can sort this. So there's electronegativity, there's ionization energy, here's radius. You can sort this by over 20 different properties. And that is what scientists did when they created the periodic table, was as they learned more and more about each atom and how they had these certain properties, it was very easy for them to sort them into this funky little shape here. So anyways, what we're going to do is we are going to graph these. Okay, so very simple. We know that our independent variable is the atom, and that's going to be on our x-axis. So our atom or element is going to be on our x-axis. And then we're first going to do a graph for ionization energy. So our question is, how does the element affect ionization energy? Or as you increase through the periodic table, how does the ionization energy change of these different elements? So in order to answer that question, we need to select our data. So starting with hydrogen, so I'm putting my mouse over hydrogen. I'm going to click down to select the cell. And then I'm just going to drag down to select all of the atoms through krypton, and then go one column over to select those ionization energies. I'm going to insert a chart. And when I do that, Google Sheets, my default is a bar graph, but I'm going to come over here to chart type, and we're actually going to, we're going to go over here and change this to a line graph so that we can see what that trend looks like. We can move this out of our way so that we can still look at the other data. And you can see that it did graph how we would like for it to. We've got our dependent variable, ionization energy on our y-axis, and then we have each element as our independent variable on our x-axis. And then you might even go ahead and change the name to the question that we're trying to answer, and we do that over here on the customize. So we'll go to chart and axis titles, our chart title. The chart title here is how does ionization energy change as the atom changes. Right, so how does ionization energy change as the atom is also changing? Then we're also going to do that same graph, except we're going to have atomic radius as our dependent variable, and then we'll have electronegativity as our dependent variable. So we're actually going to end up with 3 different graphs. And I already did this in another tab, but you should have something that looks like this. And I'll actually just show you guys how to do this really fast. So I'm going to copy everything in A, so Control C, and, oh, maybe not. Never mind. We'll just do it here in this same sheet, that's fine, as long as you get the graph created. So we'll just highlight all of the atoms again in column A, and then I need to select atomic radius. So I'm going to hold down the Control key, and then I'm going to come over here and select all of these values. And we're going to go back up to Insert. Once you have your data selected, we'll go to Insert, Chart. And again, mine is set to this bar graph. So I'm going to come over here and change that to line. And then we'll change the chart title to How Does the Atomic Radius Change as the Atoms Change? And that's done. You get this really nice little graph here that shows you what's happening to the size, and this is in picometers, so it's pretty tiny. All right, and we'll just move this graph out of the way so that we can go grab our electronegativity data for the last graph. Come on. There we go. Okay, and so starting off the same way, we're going to select all of our atoms, and I'm just clicking and that hydrogen, dragging down, hold down the Control button, and then go highlight your electronegativity values. Electronegativity, we've talked about that a little bit in class, about how that is the atom's pull for electrons, and the higher they're closer to 4, the higher the pull. So we got our data selected. We'll insert chart, change that to line graph. We'll go change its chart title. How does electronegativity change? And it does not think that that's a word, but it is. How does electronegativity change as the atom changes? All right, and this is done as well. Again, you have this nice little graph showing you from hydrogen to helium what's occurring, and then starting period 2 with lithium, going all the way up to neon, drops back down, sodium, magnesium, to chlorine, and then drops down to argon. So why do you think on those noble gases we're seeing a big decrease to 0 on their pull for electrons? Why do you think that those noble gases have a very low pull for electrons? Okay, so now that you've got your 3 graphs created, you can go back up to the Google Doc and start answering these questions. So for ionization energy, create a graph using the data. Okay, we did that. Define what ionization energy is. I'll let you guys find that on your own. Use a graph to determine the trend as you move down a group Okay, so down a group, which is a column, and then use the graph to determine the trend as you move across a period or row. So we'll do that period row one first. We'll do that together. So for ionization energy, as you move across a row, so we know in the first row we've got hydrogen to helium. You should be able to see a little trend there. We jump down to the second row, starting over here with lithium. And here's lithium. Looks like ionization energy of 513. Beryllium, 899. Boron has like a slight decrease of 801. But overall, you should see this trend. To me, it seems like it's increasing. And then you get to neon, which is 2081. So across that one row, we started at 513 to 2081. So you should see a trend there. And then if we're going down a group, let's just look at group one. So in group one, we've got hydrogen, lithium, sodium, potassium that we should have graphed. We just graphed the first four rows. So starting with hydrogen, then lithium, sodium, potassium. So for hydrogen, it was 1,312. For lithium, 513. Sodium, 496. And then last, potassium, 419. So you should be able to answer questions 3 and 4 just from that information. And then number 5, on the representation of the periodic table below, draw arrows representing increasing ionization energy. So how did it increase based on number 3 and number 4? So for number 4, you should have seen it increasing as you were going across. So you'll go insert. Let's see. Trying to find the option for arrows, and it's not looking like it's popping up. I may even just print this off for you guys, that way you can draw your arrows in. But for question 4, as you go across the period, the ionization energy the arrow would need to be drawn this direction. And then as you were going down a group, it was decreasing. So if it wants us to draw arrows with increasing, our arrow needs to go up and down this direction. Okay? So I've shown you guys how to make the graphs. I've shown you how to read the graphs. Your job will then be to answer the questions on electronegativity and atomic radius. If you have any questions, please let me know.